Good evening, students. Once again, I am very glad to meet you in another one webinar. This webinar consists of types of metals and alloys. Types of metals and alloys. This webinar mainly focus on what are the metals available in our world widely, and also what are the alloys, which kind of alloys are mainly available, and what are the applications of metals and alloys. And also this webinar focus on the types of steels. Also we are going to see this in this webinar. Okay. First of all, we have to see about the metals. What is metal? What are the types of metals? So in our world, widely two metals are available. One is ferrous metal, another one is non-ferrous metal. What is ferrous metal? If the iron contents are mixing in the metal, that is ferrous. So iron-based metals are known as ferrous metals. So iron-based alloy is known as steel and cast iron. Then without iron content, if the alloys are available, that alloys are known as non-ferrous alloys or non-ferrous metals. So examples for ferrous alloys is steel and cast iron. So examples for non-ferrous metal, that is aluminum and copper, magnesium. The examples for non-ferrous alloys are brass, bronze, invar metal, etc. So in this webinar, we are going to focus on the details about the alloys. Mainly focus on the ferrous alloys and also non-ferrous alloys. So next we are going to see about the ferrous alloys. So mainly ferrous alloys will be classified as steels and cast iron. What is steel? Mainly all the industries and commercial purpose and homely made vessels are made up of steel. So steel is very, very important metal which we are handling very widely in our daily life. So what is steel? What is the composition of steel? That we are going to see in this webinar. So first of all, mainly steels are classified as two, that is low alloy steel and high alloy steel. Steel is an alloy which consists of the carbon content, mainly carbon content and chromium content. So steels are mainly classified as low alloy steel and high alloy steel. Low alloy steel means if the steels are consist of carbon with less percentage of carbon, that is steel, that is low alloy steel. If the high alloy steel means if the steels are consist of more amount of chromium, that is high alloy steel. So now we are going to see about the details. So first of all, the low alloy steel. So low alloy steel, mainly steels are the alloys of iron and carbon. So low alloy steel means the steel consists of the carbon with less amount. So mainly low alloy steels are classified as low carbon steel, medium carbon steel, and high carbon steel. So low carbon steel means if the steel consists of 0 to 0.25% of carbon, that is low carbon steel. So our daily used mild steel, that is MS, mild steels are the category of low carbon. So mild steel is also one of the low carbon steel. Then medium carbon steel. Medium carbon steel consists of the carbon percentage of 0.25 to 0.6%. Then another one classification is high carbon steel. So high carbon steel consists of 0.6 to 1.4% of carbon. So in industrial purpose, all the tools and cutting tools Then the tools used for various machines are mainly made up of high carbon steel. So, if the carbon contents are mixing with the steel, that is low alloy steel. Then high alloy steel. High alloy steel means without the carbon, another element, that is chromium. If the chromium is mixing with the stained steel with 11 percentage of volume, that is stainless steel. In our homemade products like the plates, then home vessels, homely used containers, these are made up of stainless steel. So stainless steel is very important material which we are daily used in our homely purpose. Then tool steel. Tool steel means the industrial purpose steel. So the industrial purpose steel, that is tools are used for fittings, smithy, then plumbing work. The tool steel is used. Tool steel is used. Then, as I told in earlier, the carbon contents percentage, according to the carbon contents percentage, low carbon, medium carbon, and high carbon steels. And also, another one classification is according to the iron carbon equilibrium diagram, the carbon contents, according to the carbon content percentage, there is two types of steel, that is hypoeutectoid steels and hypereutectoid steels. Now, we are going to see about the applications of low carbon steel. As I mentioned earlier, the 0 to 0.25 percentage of carbon available in the low carbon steel. So mainly, low carbon steel property is very soft material. Low carbon steel is very soft, but outstanding ductility material. Ductile material. Ductile material means it is ability to make thin sheets, that is ductility. So ductile property is more in the steel, low carbon steel. Then low carbon steel is having good machinability and weldability. So mainly mild steel is very much example for low carbon steel. The advantage of low carbon steel is it is least expensive to produce. It can be easily machinable. But the disadvantage of low carbon steel is unresponsive to hardening heat treatment, because martensite is difficult to form owing to very low carbon content. So it cannot be hardened and it cannot be subjected to heat treatment. That is the disadvantage of low carbon steel. Mainly mild steels are used in automobile body parts and manufacturing of structural shapes, and also it is used in building materials and bricks and small cans. Also the low carbon steel is used. Then medium carbon steel, as I mentioned, 0.25 percentage to 0.55 percentage of carbon is available in the medium carbon steel. It is mixed with iron. So mainly properties of medium carbon steel is it is very much stronger than low carbon steel and less tougher than low carbon steel. Then advantages of medium carbon steel is best range for adding alloying elements and good mix of strength and ductility. Then mainly medium carbon steels are used in railway wheels and tracks, and also the gears which are used in the gearbox of automobiles are very much made up of medium carbon steel, and also crankshaft. Crankshaft is mainly used in the IC engines and also steam engine. This crankshaft is made up of medium carbon steel, and also some machine parts are also manufactured by medium carbon steel. Then high carbon steel. The high carbon steel, the the carbon percentage is 0.55 to 2.1%. Mainly high carbon steel properties are very much hardest, strongest, and least ductile. Applications of high carbon steels are knives, razors, hacksaw blades, and high strength wires, and also industrial purposed cutting tools are made up of high carbon steel. Now we are going to move on alloy steels. Alloy steels are mainly classified as structural steels, tool and die steels, magnetic steels, and stainless steel and heat resisting steels. Now, if the carbon percentage is more than 2 in the iron content, that is known as cast iron. So, in steel, maximum the carbon percentage is up to 2%. If the 2% to 4% of carbon is available in the iron, it will become cast iron. So cast iron is a very much brittle material. So if the carbon contents are more than 2% in the steel, it will become brittle from the ductile. So cast iron consists of 2.1 to 4% of carbon. So mainly types of cast iron. So cast irons are classified as grey cast iron, white cast iron, malleable cast iron, nodular or SG iron or ductile iron. So in the iron carbon equilibrium diagram, if the carbon content is from 2.1 to 4.3%, it is hypoeutectic cast iron. If the carbon content is 4.3 to 6.6, it is hypereutectic cast iron. So mainly grey cast irons are widely used. So grey cast irons are mainly applied in pressure vessels, cylinder heads, pistons, clutch plates, and base structure for machines, that is foundation of machines and heavy equipments that are exposed to vibrations, valves, fittings, and levers. So cast irons are mainly used for manufacturing the IC engine parts. So grey cast iron is widely used for making IC engines. Then white cast iron. White cast iron is mainly applied in liners for cement mixers, ball mills, and drawing dies and extrusion nozzles. So mainly the aircraft engine nozzles are mainly used by white cast iron. So before that, the carbon content from 2.5% to 4.4% is grey cast iron, then 1.8% to 3.2% of carbon, then silicon, and the rest iron is also mixing with the steel for making white cast iron. Then malleable cast iron. In the malleable cast iron composition is 1.8% to 3.2% carbon and 0.3% to 1.8% silicon, remaining is iron. So malleable cast iron is mainly used for making connecting rods, transmission gears, flanges, pipe fittings, differential cases for automotive industries, valves, parts for railroads, and marine works. So most of the IC engine parts are manufactured by malleable cast iron. Then graphite iron. So graphite iron, 3 to 4% of carbon, 1.6% to 2.8% silicon, remaining is iron. So This graphite iron is mainly used for making flywheel in the IC engine, furnace doors, wrenches, lathe chucks, motor frames, and pump bodies. Now we are going to see non-ferrous alloys. So far we have studied about the ferrous alloys, which are the iron contents. Now we are going to see non-ferrous alloys. Non-ferrous alloys means if the alloys are having without steel content, that is iron content, that is non-ferrous alloys. So non-ferrous alloys applications and some compositions we are going to see. First of all, copper alloys. So copper alloys, the examples for copper alloys is brass, bronze. Brass consists of high percentage of copper and a small percentage of zinc. It is a mainly corrosion resistant material. It is used for making costume, jewelry and coins. Then second copper alloy is bronze. In this bronze, most of the percentages consist of copper and less percentage of Sn. Then aluminum, silicon and nickel also mixed with the copper for making bronze. So applications of bronze is bushings, which are used in the machine parts, and landing gears, which are used for aircrafts, are made up of bronze. Then titanium alloys. So titanium alloys consist of the titanium having more percentage and some other materials having very less percentage. So titanium alloys are mainly used for space vehicles and also biomedical applications. Then aluminum alloys. So aluminum alloys mainly consist of invar, that is having more percentage of aluminum and less percentage of copper, magnesium, silicon, manganese and zinc. Aluminum alloys are mainly used for making structural components in the aircraft parts and packaging materials. Then magnesium alloys. Magnesium alloys having more percentage of magnesium and very less percentage of copper and aluminum. So magnesium alloys are used for making aircraft parts and missiles parts. So copper is one of the earliest material discovered by man. So copper is mainly used for making coins. So electrical and construction industries also are used for copper. So the properties of copper that are main important is ductile material. Copper is ductile material and it is very high electrical conductivity material. Then it is a excellent thermal conductivity material. So it is used for making cooker, that is pressure cooker, which is used in home for making rice. So copper bottom cooker. So copper bottom cooker means the copper plate is fixed with the bottom of the stainless steel cooker. So copper is mainly used for thermal conductivity material. So copper alloys are mainly examples for copper alloys is brass, phosphor bronze, then aluminum bronze, silicon bronze, and copper nickel silver. So brass consists of copper and zinc. Phosphor bronze consists of copper and tin. Aluminum bronze consists of copper and aluminum. And silicon bronze consists of copper and silicon. Then bronze. Bronze is also the copper alloy, but it consists of copper, tin, lead, aluminum, silicon, and nickel. So, copper, tin, bronze is one of the earliest alloy to be discovered as copper ores invariably contain zinc, that is tin. So, bronze is mainly used for making stakeboard ball bearings, surgical and dental instruments. So, ball bearings, that is bronze bearings, mainly used for supporting the shaft in the industrial purpose. Then, beryllium copper. So, beryllium copper consists of copper and beryllium. So, it is a mainly heat treatable alloy. So, mostly this beryllium copper alloy is used for making springs, load cells, and other parts subjected to repeated loading. So, cast alloys are used in injection molds. Other applications include jet aircraft, landing, gear bearings, and bushings. So, then aluminum. Mainly, alloys of aluminum is wrought aluminum. So, wrought aluminum consists of 99% of aluminum, then very small percentage of copper, manganese, silicon, magnesium, and zinc. Then magnesium alloy. This magnesium alloy consists of magnesium having more percentage and copper and zinc having very low percentage. Aluminum, zinc having very low percentage. So wrought alloys are available in rod, bar, sheet, plate, forging, and extrusions. So so far we have studied about the ferrous alloys and non-ferrous alloys. So mainly we have focused on ferrous alloys which having steel and cast iron. So thank you so much for your patience watching. In next my webinar, we are going to see the alloys of steel according with the iron carbon equilibrium diagram. So in next webinar, we will see about the iron carbon equilibrium diagram consists of the different microstructures and phases of steels and cast iron. Thank you.
I hope you have understood the concept. If you have any doubt, need clarification, or want to learn this course, don't hesitate to contact Life Changers Academy. Please fill out the registration form to join the course. Get your certificate for this session by providing your details in the below form link. The form link will be available only 72 hours. Learn new courses from basic to advanced level at an affordable price with the guidance of industry experts. If you think this session is useful, like it, comment below and share it with your friends. Let them learn and earn certificate at low prices on their interested courses. Please subscribe to our channel and click on the bell icon for more learning updates. Thank you.